You want to become a DevOps engineer but don't know where to start? Don't worry. In this video I will show you a complete roadmap in 5 steps that will help you in becoming a DevOps engineer from beginner to pro. Let's dive in. A DevOps engineer is the bridge between software development and IT operations. They automate processes, manage infrastructure, and ensure smooth deployment of applications. DevOps is a set of practices, tools, and cultural philosophies that aims to improve collaboration and communication between software development, dev, and IT operations, ops, teams. The goal is to shorten the software development lifecycle, increase deployment frequency, and ensure higher quality software. In short, DevOps aims to streamline the development, testing, deployment, and monitoring of applications to create faster, more reliable, and efficient software delivery processes. Step 1. Learn the basics. Before jumping into DevOps, you need a strong foundation in IT and software development. Here's what you should focus on. 1. Operating systems. Learn Linux and basic shell scripting. As a DevOps engineer, having a solid understanding of operating systems is crucial because the operating systems is where most of the applications and infrastructure run. Here are key areas of operating systems you should focus on learning to be effective in a DevOps role. Basic commands. File system structure and permissions. Networking commands. Log file management. Basic shell scripting. 2. Clear networking basics. Understanding networking basics is crucial for a DevOps engineer because networking plays a vital role in connecting distributed systems, services, and applications. DevOps often involves managing infrastructure, deploying applications, and ensuring smooth communication between various components in both on-premises and cloud environments. Here's a breakdown of networking basics every DevOps engineer should know. First, understand IPs. An IP address is a unique identifier for a device or server on a network. It allows devices to communicate with each other over a network. Then learn about DNS. It is like the phone book of the Internet, translating human-readable domain names like www.example.com into machine-readable IP addresses. 3. Programming languages. Learn Python or Bash for automation. Programming languages are important for a DevOps engineer for several reasons, as they play a key role in automating processes, improving efficiency, and managing the infrastructure effectively. DevOps engineers are responsible for automating repetitive tasks like testing, deployment, configuration, and monitoring. Programming languages help in creating scripts to automate these processes, which is one of the core principles of DevOps. 4. Version control. Master Git and GitHub. Learning Git and GitHub is incredibly important for a DevOps engineer because these tools play a crucial role in managing code, automating workflows, and ensuring smooth collaboration between development and operations teams. Here's why mastering Git and GitHub is essential for a DevOps engineer. Git is the most widely used version control system, VCS, and GitHub is one of the most popular platforms for hosting Git repositories. A DevOps engineer needs to understand version control to efficiently track changes to code, configuration files, and scripts. With Git, engineers can maintain a history of changes to infrastructure, scripts, and application code, making it easy to roll back to previous versions, compare different code versions, and collaborate on the same code base without conflicts. Through GitHub, teams can collaborate by creating pull requests, reviewing changes, and commenting on them before merging. This is especially important in a DevOps environment where automation, testing, and deployment are critical parts of the process. Step 2 of DevOps Roadmap. Master CI/CD pipelines. Learning CI/CD, continuous integration/continuous deployment, is critical for a DevOps engineer because these practices form the backbone of modern software development and operations. CI/CD allows teams to deliver software faster, with higher quality and fewer manual interventions, all of which are essential in a DevOps environment. Let's discuss the key reasons why CI/CD is important for a DevOps engineer. 1. Automation of the development pipeline. CI/CD automates the process of integrating code changes and deploying them into production. In a traditional environment, this was done manually, which was error-prone and time-consuming. By automating this pipeline, DevOps engineers can ensure a smoother, faster, and more reliable process. 2. Faster delivery of software. CI/CD significantly speeds up the process of moving code from development to production. DevOps engineers set up automated build and deployment pipelines, ensuring that code changes can be tested and deployed within minutes, rather than waiting for days or weeks. 3. Reduced risk and increased reliability. Continuous integration ensures that code is tested early and often. By running automated tests on every integration, such as unit tests, integration tests, and static code analysis, the likelihood of bugs slipping through into production is minimized. Continuous deployment reduces human error during the release process by automating the deployment pipeline. This means fewer manual interventions and a more reliable release process. It also allows for quick rollback if an issue is detected in production. As systems grow more complex, scaling operations can become challenging. CI/CD tools, such as Jenkins, GitLab CI, Circle CI, and others, allow DevOps engineers to scale their deployment pipelines to handle more projects, environments, and teams. Mastering CI/CD enables DevOps engineers to create a more efficient, responsive, and resilient software delivery process, which is crucial for meeting business objectives and maintaining high-quality products. Step 3. Learn infrastructure as code. Learning infrastructure as code is essential for a DevOps engineer because it aligns perfectly with the core principles of DevOps: automation, collaboration, and efficient management of infrastructure. Infrastructure as code allows DevOps engineers to manage, provision, and maintain infrastructure using code, making processes more consistent, scalable, and reliable. Infrastructure as code allows for the automation of infrastructure provisioning, configuration, and management, eliminating the need for manual intervention. DevOps engineers can write code to automatically spin up, configure, and tear down servers, networks, databases, and more, making it faster and more reliable than manual processes. With infrastructure as code, infrastructure definitions, such as server configurations or networking setups, are stored as code in version control systems like Git. This allows teams to track changes, roll back to previous versions, and understand the history of infrastructure modifications. By using tools like Terraform, Ansible, Puppet, or CloudFormation, DevOps engineers can quickly provision and configure infrastructure in a reproducible manner. Whether it's creating virtual machines, databases, or entire networks, the process is automated and can happen in a fraction of the time compared to manual setups. Step 4. Cloud platforms and monitoring. Knowing basic of cloud platforms and monitoring is crucial for DevOps engineers because both are foundational to modern software development, deployment, and maintenance. Cloud platforms provide the infrastructure to run applications, while monitoring ensures that these applications and systems perform optimally. Here's why these skills are important. Number 1. Cloud platforms enable scalability and flexibility. Cloud platforms like AWS, Azure, and Google Cloud are essential for DevOps because they allow you to easily provision, scale, and manage infrastructure on demand. DevOps engineers need to be familiar with these platforms to deploy applications, manage virtual machines, set up storage, and configure networking, essential tasks in a dynamic, cloud-based environment. Elasticity is a core feature of cloud environments, allowing businesses to scale their applications up or down based on demand. Understanding how to manage resources efficiently in the cloud is critical for optimizing performance and controlling costs. Number 2. Monitoring. It ensures performance and reliability. Monitoring is vital to ensuring that applications and infrastructure are running smoothly. In the context of DevOps, monitoring involves tracking metrics such as CPU usage, memory usage, response times, and error rates. Tools like Prometheus, Grafana, CloudWatch, AWS, and Azure Monitor allow DevOps engineers to gain real-time insights into system health, application performance, and infrastructure status. This enables proactive issue resolution before they impact users. With proper monitoring in place, DevOps engineers can quickly identify bottlenecks, failures, or performance degradation in production systems, ensuring uptime and a positive user experience. Mastering cloud platforms and monitoring empowers DevOps engineers to automate processes, optimize resources, ensure reliability, and deliver superior performance, making them key to modern software development and operations. Final step of DevOps Roadmap. Step 5. Build real projects and get certified. Now that you have the skills, build real-world projects to showcase your knowledge. Here are some ideas. 1. Set up a CI/CD pipeline for a personal project. 2. Deploy a web application using Kubernetes on AWS. 3. Automate cloud infrastructure with Terraform. You can also get certifications like 1. AWS Certified DevOps Engineer. 2. Certified Kubernetes Administrator, CKA. 3. Docker Certified Associate. To boost your career. Lastly, becoming a DevOps engineer takes time and practice, but if you follow this roadmap, you'll be on the right track. Start with the basics, learn automation, work with cloud platforms, and build real projects. If this video helped you, don't forget to hit the like button, subscribe for more tech content, and drop a comment below. What's your favorite DevOps tool? See you in the next video.